Up until now, we've really been talking separately about energy, momentum, and forces. So it's time to connect all three of those things together. So remember when we talked about kinetic energy, we said the kinetic energy is 1/2 the mass of the particle times its velocity squared. Also recall that the momentum is equal to mass times velocity. So momentum squared is just momentum dot momentum, which is p squared. So this is just equal to m squared v squared. So in other words, the kinetic energy is p squared over 2m. So that's another way to write kinetic energy in terms of momentum. Okay, but now let's say, so again, this is for something that has a constant momentum. But remember, we know that we can change our momentum, and we talked about how force and momentum are related. So now let's look at how changing momentum changes the energy. So again, let's say we have some momentum p, and then it changes because we add some infinitesimal piece of momentum. We add some small impulse, very, very, very small impulse. Okay? So if we do that, then we notice now p dot p becomes p plus dp squared, which is p squared plus p dot dp plus dp squared. So that tells us that kinetic energy can also be written as p squared over 2m, which is our initial kinetic energy, plus we have a new term that is p dot the impulse over 2m plus some term that's infinitesimally small, which is basically 0, because we're saying this anytime we have an infinitesimal and we square it, and that's of the order of dp squared, and so we just ignore that. Okay, so now let's take a look at what we have left then. So remember that momentum is just mass times velocity. So if we look back at this term, we see this is really a mass times a velocity dot our change in impulse over 2m. The masses cancel out. I made a mistake here. Since I squared this, there should have been a 2 here. So that 2 comes down to here. So those two 2's also cancel out. So that 2's gone. So we just have something that looks like v dot dp. Okay? And so your book defines this quantity, v dot dp, as k work. So an infinitesimal change in the kinetic energy. So in other words, our final kinetic energy is equal to our initial kinetic energy plus k work, this small amount of energy added. Okay? But now if I want to get the total energy, then I need to integrate this. And so if I integrate this, so the integral of dk is what we call work. So the final kinetic energy is really just the initial kinetic energy plus the work done to the system. So work is really energy that we're adding to the system. And so we notice that this is just the integral of v dot dp. And so then in the next video, we're going to show a little bit more how this work is connected to a force, and how now we'll completely complete the picture that connects forces, energy, and momentum.